welcome to another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 10, Lesson number 7, on linear regression on the calculator. Before we begin this topic, let me remind you that you can find a worksheet and a homework assignment that go along with this video by clicking on its description, or by visiting our website at www.emathinstruction.com. As well, don't forget about the QR codes at the top of every worksheet. You can scan that code with your smartphone or with a tablet, and it'll bring you right to the video associated with that lesson. All right, let's begin. Now, this lesson is all about using your calculator to do some of the analysis that we did in the last lesson. So, make sure that you have it, all right? But let's take a look. We're going to go right back to that survey of low and high temperatures that we hand plotted a scatter plot for last time. But this time, we're going to have our calculator do it. In fact, letter A says, enter data into lists on your calculator and create a scatter plot using your graphing technology. Size the window appropriately so that the data takes up the majority of the screen. Compare this to the scatter plot you created in the last lesson. All right, so I don't know where my pen is. Hold on. Do I have it now? Oh, I do. Excellent. All right. Hello, pen. There we go. Took a little while to become responsive, but we have it now. Excellent. All good. So let's bring open the TI-84 Plus right now. All right. There's my calculator. Okay, so we need to enter data into lists. We've done that before, but let's review how to do it. Find that Stat button right there. Let's hit it. Now let's go into Edit. Okay, if you have data in L1, what I want you to do is go up and hit Clear. If you have data in L2, also go up and hit Clear and Enter. And now what we're going to do is we're going to enter the low temperature data, the input data, our X if you will, in L1, and we'll enter our Y data in L2. All right, so let's do that. Let's put in L1, 26, 28, 30, 32, 34, 35, 37, 38, 41, and 45. As always, good idea to check over the data. All right. But let's not spend too much time on that. Let's go back up, pop over into L2. Let's put in 49, and that 49's got to be in the same sort of row as the 26. So 49, 50, 57, 54, 60, 58, 64, 66, 63, and 72. Again, once the data's in there, you want to check it over. One way of knowing that you've made a mistake is if these two lists don't have the same amount of data in them. All right, obviously, for every low temperature, there's got to be a high temperature. All right, but check over the data, and as soon as you feel comfortable, we are going to create a stat plot for the first time. This is kind of cool. Now, notice right above y equals, right up here, there's something called stat plot. So I want you to hit the second button and hit the y equals, and that pops us into stat plot. It's really rather cool. All right. Now, what we see is we see plot 1, plot 2, etc. What we're going to do is we're going to turn plot 1 on. So we're going to go into plot 1, and if the on isn't already highlighted, we're going to do that. Now, you know, it's probably not highlighted. You probably didn't have a stat plot on, so you're going to turn it on. And then you have to tell it what kind of plot to make. Now, the first one on here is the scatter plot. They're not, you know, they don't have names just sitting there. Notice, though, you can see the histogram. You can also see the box plot, i.e. the box and whiskers diagrams that we saw from a few lessons ago. So yes, this calculator does have the ability to make those for you. We didn't do those on the calculator because they're relatively easy to do by hand. Perhaps your teacher showed you though. All right. The point is we're going to highlight the first one though, the scatter plot. Now, as soon as we do that, it prompts us to do some other things, like tell it what the X list is and what the Y list is. Now normally those are going to be set as L1 and L2. And if they are already, then you're good to go. If they aren't, you have to put L1 in as your X list and put L2 in as your Y list. Okay? You can also choose what kind of mark you want. Do you want it to be a square, a little plus, a little dot, right? So those are your options. I tend to put it on the square because I actually want the biggest one I can get. Okay? So I've got that all set. I still need to set up my window. Now, how do you choose an appropriate window? Okay, well, this is what I do. All right, let's pop into the window right now. Let's go second window. Okay, what I do is I literally look for the smallest value in my low temperatures, right? And if I scan across that, there's my smallest low. And then I look for my largest low temperature, and here it is. No great surprise, okay? Now I want to set my window so that those two values and everything in between, obviously, are included. What should I set that at? Well, I think I'm going to set my X minimum to be equal to 20. And I'll set my X maximum to be equal to 50. Now there's nothing magical about that. You could do 26 to 45, but I like to have just a little bit of extra space, just a little bit. All right, likewise, when we're thinking about our Y min and our Y max, well, here's our smallest high temperature, and here's our largest, so that's not very tricky. We're going to get one later that makes it a little bit harder. But I think I'm going to set my Y min to be, I think, 45, and I'll set my Y max to be, I think, 75, right? So that'll get in my 49, and it'll also get in my 72. All right? So X min is 20, X max is 50, Y min is 45, Y max is 75. Your own teacher might show you other different ways to do this. That's the way that I do it. But once we have that, once the stat plot is on, then we're all set. All right? One last thing I should point out. Ideally, for right now, I don't particularly want any equations in y equals. So let's hit y equals right now and see if there's any equations in there. If there are, I'm going to clear them out. So my calculator normally has them in there, so I'm going to clear out any equations. And now I'm ready. Let me hit graph. All right, look at that. It's a scatter plot. And it's a scatter plot. I would try to redo it right now. But it's a scatter plot that looks very similar to the one that we had, right? It's got all those values. And again, I'm not going to even try. Actually, I'm saying that and then I'm trying. But I'm not going to try to do it very accurately. All right, so we got some scatter plot. Okay? And remember, when we had that scatter plot, remember how we drew that line of best fit, right? And it kind of did something like this. Okay? Well, your calculator has the ability to give you that equation, to actually give you the equation for the line of best fit. All right? We can do that. So that's what I'm going to show you next in letter B. All right? And we're going to do it on the calculator, so we're going to keep the TI-84 Plus open. And what we're now going to do is we're going to hit the stat button again. Okay, we can do it right from this screen. Just hit the stat button. All right, and we're going to go over to the calculate menu. All right, and we're going to go down to Lin regression. Okay, not like Jeremy Lin, the basketball player, but linear regression. All right, so scan down a little bit until you get to choice, on my calculator, choice 4, linear regression. Notice how it says parentheses AX plus B. Okay, hit enter on that, and what that does is it pops you out to the main screen. Okay, so I've hit enter, I'm popped out to the main screen. If my data is in L1 and L2, we're good at this point. We can just hit enter and it's going to get the job done. And our data is in L1 and L2, and that's where I really always want it when I'm doing bivariate data analysis. So I'm just going to hit enter. Now there's a lot of different stuff on the screen, a lot of different stuff. But ultimately what calculators will do whenever you have a regression equation is that they will give you the generic form, y equals ax plus b, And then they'll give you the value of A, which in this case, I got to look over at my cheat sheet, is 1.1626. And they'll give you the value of B, in this case, 19.0736. But you still want to put them together in the model. And what they say, it says round the slope of the line to the nearest hundredth. Okay, so that would be 1.16x. And the y-intercept to the nearest integer, so that would be 19. And there is the equation of the line of best fit. Now it says compare this slope to the one you found in the last lesson. So remember when we drew it by hand, right, we came up with a slope of 1.12 or 1.25. 1.25. Sorry about that little beep. It's just telling me I have an email that came in. I should mute my computer. But we've got a slope of 1.16, and we had one as 1.25. Are those close? Yeah, they're actually pretty good, right? If I rounded this one to the nearest tenth, it would be 1.2. That one would be 1.3, but yeah, I'm pretty happy with that. I don't have too much of a problem with it. So, the calculator can find the best line that fits data, and that's how you do it. All right. Now, we're going to do some interpretation of this, but I'm going to clear out the text, so pause the video now if you need to. All right, here it goes. All right, and I think I'm going to put my computer on mute too. There we go. Thank you, Macintosh. No more little beeps here and there. Okay, so there's my model, 1.16x plus 19. All right. Letter C. Explain what the y-intercept of this model represents in terms of the low and high temperatures that are being modeled in this problem. So, what does this represent? How would you describe that? And don't just say it's the y-intercept. That's not very good. Pause the video now and tell me what that 19 represents. All right. Well, think about this for a minute. The 19 is really an output value. Specifically, it's the output, the 19. Now, this isn't really part of my explanation. It's part of my explanation to you, but it's not part of the explanation I would give if I were a student. 19 is the output when the input is x equals 0. Well, what is the input? It's the low temperature. In other words, the model predicts a high temperature of 19 degrees Fahrenheit when the low temperature is 0 degrees Fahrenheit. Now, those of you watching this out in California or down in Virginia are probably going, well, we're never hitting that. And that might be the case. But for those of us in upstate New York, or maybe anywhere in New York, including the city, you can definitely have low temperatures of 0 degrees, and a high temperature of 19 then doesn't seem too unreasonable. Let's take a look at D, though. D asks us how we would interpret the slope of this model in terms of how the low and high temperatures change with respect to each other. This one's trickier. I want you to pause the video and see if you can interpret that slope, right? The slope of 1.16, all right? All right, well, here's the key, always in interpreting slopes. Every slope is a rate. Every slope is a rate. It's how fast the numerator is changing, which is the high temperature, compared to the low temperature. Now you might say, but that's not as a fraction. Okay, let's make it a fraction. So this is great, because watch how I can interpret it. For every 1 degree Fahrenheit increase, that looks a little funny. Let me do this. For every 1 degree Fahrenheit increase in the low temperature, the high temperature increases by 1.16 degrees Fahrenheit. Think about just graphing a line. I go over 1, up 1.16. I go over 1, up 1.16. So that's the way we always interpret slope, right? Which is for an increase in 1 unit in the input variable, how much increase do you get, or decrease if it's negative, if the slope's negative, how much increase do you get in the dependent variable, in the output? So for every 1 degree that the low temperature goes up, we would expect the high temperature to go up 1.16 degrees. That's it. All right, so I'm going to clear this out. Very important screen. Pause it now. Really think hard about what we did here. All right, clearing it out. Let's keep working here. Exercise 2. Generally, the fuel efficiency of a car changes with the weight of a car. A survey of some cars with their weights and gas mileages is shown below. All right, so let's take a look at this table and really make sure that we understand what's going on with it. All right, so what it's saying is that when the weight of a car is 3.7 thousand pounds, because you don't get cars that weigh 3.7 pounds, but 3.7 thousand pounds, the mileage is 38 miles per gallon. On the other hand, here we've got a very large vehicle at 5.1 thousand pounds, and it gets gas mileage of 24 miles to the gallon. All right, so before you ever do anything in math, especially with data, make sure you understand it. Okay? Now, letter A says find the equation for the line of best fit using your calculator. Round both coefficients to the nearest tenth. List what the variables x and y represent in this problem. Now, this is a very, very new procedure, so I want to make sure that you really understand how to do it. We put the TI-84 away a few pages ago, a few problems ago, so we're going to bring it back out, okay? Here it comes. Oh, that sounded a little bit loud. Sorry if it shocked you or woke you up. So we've got the TI-84 Plus open. Let's go into our Stat menu. Okay, let's go up to Edit. We've probably got the data in there from that high-low temperature problem that we just did. So let's go up to L1, highlight it. Hit the clear button. Remember, never hit the delete button. Hit clear, enter. That data's gone. Let's take our cursor over now, bring it up to the L2, hit clear, enter, and that data's gone. Let's go back to L1. Let's get in the weight, right? So unless otherwise told, when I'm given a table, I will always assume that the first row or column represents X, i.e. L1, and the second row or column represents Y, or L2. So in L1, let's do it. Let's put in 3.7, 4.5, 3.2, 5.1, 6.8, 4.9, 4.8, and 5.5. Again, doesn't hurt to spend just a few moments looking to make sure you've got the data in correctly. All right, let's go back up, up, and let's go over to L2. Let's put in 38, 26, 48, 24, 18, 30, 28, and 21. Again, you step back, you relax, you look at L2, you make sure you put it in correctly. Again, one of the big red flags is you've got more data in L1 than L2 or vice versa, right? You got to have the same amount in a bivariate data problem. But assuming it all looks good, let's get that line of best fit. Remember how we do that. We hit the Stat button. We go over to Calculate. We head on past one var stats, which we did a little while ago. We go down to Lin regression. All right. We hit enter. That brings us out to the main screen. We now hit enter again. Bing, bang, boom. There's our model. Again, they will always list that generic model first, y equals ax plus b. I know you want that to be an m, but it just isn't. The a value in this case, again, pardon me for having to stare over at my little cheat sheet, negative 8.097. The y-intercept, 68.093, etc. Round both coefficients to the nearest tenth, so my model will be y equals negative 8.1x plus 68.1. Excellent. There's my model. Now notice what I've also asked you to do. I've also asked you to list what the variables x and y represent in this problem. Strangely enough, I think one of the biggest issues students have with linear regression is they put the data in, they crank through it all, they get a final answer, and then they don't know what x and y represents. So be clear, x is the weight. Is the weight of the car. All right? And y is the mileage. And I'm going to put miles per gallon. All right, we want to keep that in our head, crystal clear in our head. Okay? So let's set up a stat plot. Now, one of the cool things is because we just did a stat plot, we're actually completely set up. But let's walk through the process again really quickly. I mean, we're going to go pretty quick because it should be in there, but you never know. Maybe you just started watching the video right at this point. So we're going to hit second y equals. We're going to go into stat plot 1. Now again, it's already on for me. Okay, I've already selected the scatter plot. My x list already says L1. My y list already says L2. But again, it's good to make sure that's all set. I like using the square as my symbol. The one thing that isn't set is my window. My window's set up for the last problem. So what I'm going to do is I'm going to go into my window now, hit the window button. Now I have to figure out a good window. Well, when I look at my x list, my L1, the smallest value is 3.2, and the largest value is 6.8. So using those two, I'm going to set my x min to be 3, and I'm going to set my x max to be 7. Right? That works well. I don't have a lot of space for L2. But what I see is I see my smallest value being 18 and my largest value being 48. So I'm going to set my y minimum to be 15. That'll get the 18 in. And I'll set my y maximum value to be 50. So y minimum is 15, y maximum is 50. All right. Again, let's take a look. We've got x min at 3. We've got x max at 7. Y min is 15. Y max is 50. Okay. Now let's create a graph of the scatter plot. All we have to do now is hit the graph button. All right. Probably should have checked to see if any more equations were on, but given that we did that last time, I didn't really feel the need this time, and I'll be honest with you, I just forgot. So I'm not going to try to draw a perfect representation of this, but you know, we got a little bit of the data and a little bit of this stuff going on, and maybe this and this and this. Okay, yeah, that's beautiful. It then goes on and says, would you consider the correlation between weight and mileage to be positive or negative? Explain. Now this one's important, so pause the video now and give a good explanation for this. All right, let's go through it. Well, this is a really good example of a negative correlation. Not because it's a bad thing, but it's a negative correlation because as the car weight increases, sorry, I can talk faster than I can write. You ever notice that? As the car weight increases, the mileage decreases, right? So a very light car like let's say a Prius will get very, very high gas mileage. I mean, granted, that's maybe not a great example because it's a hybrid. So let's just say a very low weight car, you know, like whatever. I don't want to violate any more copyright or anything, but a very low weight car, as opposed to, let's say, a big heavy SUV, right? A big heavy SUV is going to have very low mileage. A very light car will have very high mileage. So they move in opposite directions, and that's why it's a negative correlation. And you can really see that right here, right? You can see it. In fact, if we were able to draw the line of best fit, right, what we would have is something like that. Okay, I'm going to clear this out, so write down whatever you need to. All right, here we go. There's the scatter plot. Letter C asks an interesting question. Which parameter of the linear model, remember the parameters are this, oops, that was awesome. Let me switch it back to a pen. The parameters are this and this, okay. So which one of those two predicts whether the correlation is positive or negative? Use this model to help explain your answer. All right, well, it's the slope, right? I mean, that's what slope is all about. You know, a positive slope will indicate a positive correlation. And a negative slope will indicate a negative correlation. Right. And that should make sense. In fact, that's exactly what slope does. In other words, if a slope is positive for a line, and let me draw a line of best fit back in red. I mean, that may not be the best fit line, but it's close enough, right? You know, for slope, what we're always saying is, as x increases, what does y do? So if y also increases, then slope is positive, because you get a positive divided by a positive. On the other hand, if as x increases, right, if as x increases, you get a decrease in y, well, then you get a negative divided by a positive, and you get a negative slope. All right, let's take a look at letter D. If a car had a weight of 4,300 pounds, what would this model predict as its fuel efficiency? Round to the nearest integer, use appropriate units, and make sense of your answer. See if you can do this. Use your model. Use this thing up here. I'm going to get rid of all of this. Use this model to try to predict what kind of gas mileage you'd get if your car weighed 4,300 pounds. Pause the video now. All right, well, if you put 4,300 in for x, you probably, well, you didn't probably, but you probably found that you had a negative gas mileage. All right, that doesn't make any sense. In fact, it's very important to note that the weight of the car is in thousands of pounds. So in fact, what we need to do is we need to put in 4.3 for x, not 4,300, not 43, not 0.43. So if we have 4.3 in there and we just substitute it in, right? Models can only do two things. You either put something in for x and you get y, or vice versa. But if we crank through this, and what does that come out to be? 33.27, and round to the nearest integer, so 33 miles per gallon. And that makes some sense, right? In fact, if I went up here and I found one that was relatively close, like this is relatively close, 4.5, I'm getting 26. 4.3, I'm getting 33 miles per gallon. All right? So whenever they tell you to use a regression model or any model to do a prediction, likely is they're either giving you the input and asking you for the output, or they're giving you the output and asking you for the input. All right, pause the video if you need to, because then I'm going to clear out the text. All right, one last little piece of this problem. All right, so the last part of this problem says, if we wanted to purchase a car that got 40 miles to a gallon, what weight of a car to the nearest 100 pounds should we purchase? Solve algebraically. All right, great. So in this case, notice that what they've given us when they say that we've got 40 miles to a gallon is they've given me the y, right? So at this point, what I'm going to do is I'm going to put y in, right, as 40. And now I'm going to solve this equation algebraically. So what I'd like you to do is I'd like you to pause the video for a minute, solve that, and see if you can interpret the problem, right? We want to figure out the weight of the car that we can purchase that will get us 40 miles to a gallon to the nearest 100 pounds. All right, why don't you go ahead and do that? All right, well, simple enough, right? Just an easy linear equation. We'll use the additive property of equality to subtract 68.1 from both sides. Don't get nervous about the negative. Use your calculator if you need to. Then we'll divide both sides by negative 8.1. Remember, that's the multiplicative property of equality. And let's see, that will give me 3.4691. Well, that's a little bit odd. I need to buy a car that weighs 3.5 pounds? Wait a second. Wait. Look back. No. That's X, right? That's 3.46 thousand pounds, right? Thousand. So if I actually want to know the actual weight, if I multiply that by 1,000, I'll get 3,469 pounds. All right, and I need to round that to the nearest 100 pounds. So that's going to be 3,500, and now I'll just use my nice little abbreviation for pounds, which makes no sense, LBS. All right. So that's it, right? With any kind of model, especially regression models, if you're asked to use the model, very often you're given an input and you're asked for an output. That was letter D. Or you're given an output and you're asked for an input. That's letter E. And it's not too bad. All right, I'm going to clear this out. So write down what you need to. All right, here it goes. And let's finish up the lesson. All right, so we saw actually a lot of important stuff today. If nothing else, we saw the mechanics of how to enter data in the calculator, which we had seen before, and then use the calculator to produce both a scatter plot and a line of best fit, okay? So we're going to need that for future lessons, so hold on to it, make sure you've got those skills. For now, I'd like to thank you for joining me for another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking,